Hey all you cool cats and kittens, welcome to Wednesday. Today we're going to go ahead and focus a little bit more on what are called unit vectors. Remember the definition of a unit vector. What that means is that if you find the magnitude and the magnitude is a length, the magnitude has to equal 1. Okay, so it says in many applications, so when you get to those story problems, in many applications of vectors, it's useful if you can find the unit vector. The unit vector is the vector that has a magnitude or a length of 1. So again, very similar to when we talked about the unit circle. The unit circle always keeps the radius 1. A unit vector always keeps the magnitude 1. It has the same direction as a given non-zero vector. Okay, so again, the reason why it has to be a non-zero vector, because a zero vector means your initial point and your terminal point are at the same spot. So there really isn't direction, so to speak. We have no idea where it's going. To do this, if you have a vector and you want to change it into a unit vector, this is the formula that you use. I know it can be kind of funky looking at it like this. So this is how I'm going to go ahead and show you. This was always easier for me. Okay. So to turn it into a unit vector, you take the component form. So let's say I have vector V. V sub 1, V sub 2. So on the top, you have your component form. That's what's on the top. The bottom is the distance. Remember those? It's like a double, it kind of looks like a double absolute value. What that means is the magnitude. So remember the shortcut is you would take your first component squared plus your second component squared. What this is the magnitude. So this is the first step. Now what they're showing you here is in order to use scalar multiplication, they're going to have you take that component vector and take it out back. So what that would look like is it's going to be 1 over the magnitude, vector 1, or vector sub 1, and vector sub 2. So your x value, your y value. So you do this, okay? Then what you want to do is once you know the magnitude, you're going to separate it. You're going to pull that vector out because now you can do scalar multiplication. So it allows you to go from one fraction into two fractions. And the reason why you'd want that is because you want it in that component form. You want two separate values, a horizontal value and a vertical value. Okay. So if you were to look in the book, they give you this and then they jump in. So I did leave you a little bit of space as we work through this. Hopefully it makes sense. Okay. I think best thing, jump into this. So we're going to go ahead and do 2. If at the end of 2, you're like, what just happened? Do 35, 37, 39 on page 434. Those are the questions that will most prepare you for things that are coming up, okay? Find a unit vector. Just means you have to use this formula. So if you find the magnitude, it's a 1. In the direction of your vector is -2, 5. So that means the initial point, because it's in component form, your initial point is at 0, 0. Your terminal point is left 2, up 5. And you have to verify that it actually has a magnitude of 1. So to find the unit vector, you take the component form. So -2, 5. That goes on the top. Now the bottom is the square root of the magnitude. So you take the first component and square it. -2 squared is 4. Plus the second component and square it. 5 squared is 25. So I have the component form on the top over the square root of 29. So at that point, I'm to here. Now I'm going to go ahead, you guys, and I'm going to pull 1 over the square root of 29 out front. Because now what I can do is use scalar multiplying, and rather than having one fraction, that's number 1, not in a correct form, but by doing this, I can still have that component form. I can have an x value and a y value. So if I'm distributing, I end up with -2 over the square root of 29, and I bring that in, 5 over the square root of 29. And some of you right now are saying, rationalize the denominator. Yes, all of these skills that you've learned, they carry on into vectors. We have not been able to have a square root on the bottom of a fraction since algebra 2. Now that we're working with vectors, that's still a rule. So I need to rationalize the denominator. So I'm going to multiply top and bottom by the square root of 29. And I do have to do that for both because you cannot have a square root on the bottom. So your unit vector is -2 square root of 29 over 29 and 5 square root of 29 over 29. That is your unit vector. Okay, so we found it. Then it said verified has a magnitude of 1. In order to find a magnitude, once you have your component form, you take your horizontal component, the x value, and you square it. Guys, this gets a little wild, but it's fun. Plus your vertical component, the y value, and you square that. Now what we have to prove is that this actually equals 1. If this does not equal 1, then this is not a correct unit vector because the definition of a unit vector means when you find the magnitude, it must equal 1. So we found the vector, that component form. Now we need to find the magnitude to verify it's 1. When you square a fraction, remember it goes to every single thing. So -2 squared is 4, talking at the same time here. Square cancels a square root, so it's 29 over 29 squared. If I take 29 and I take it to the power of 2, it's 841 plus 5 squared is 25 times. If you square a square root, it cancels, so you'd have 29. 29 squared is 841. Okay, so I took that 2, it goes to the number up front, it cancels the square root, it goes to the bottom. Now on the top, 4 times 29. 4 times 29, we get 116 over 841 plus 25 times 29. I just want one number in the numerator. 725 over 841. I love this. You're adding. You got a common denominator. Oh, that's fantastic. Okay, now add the numerators. 116 plus 725. You guys, it's 841. We did it. 841 divided by 841 is 1, and the square root of 1 is 1. So the magnitude of this vector is a 1. So this is a correct unit vector. You verified it, you did the proof, and you're done. Let's do another one. Okay, so I thought if we do 2 together, hopefully it makes sense. Again, there are 3 in the book that are very similar if you need extra practice. Okay. Find a unit vector that's in the direction of 8 and -20. And then, so you want it in the same direction. But it has to be a unit vector, so its length can only be 1. What would that be? So you start off, component vector is the numerator. The bottom, we have to calculate the magnitude. When you know the component form, you take the x value, the horizontal value, and square it. 8 squared is 64. Plus the vertical component, the y value, and square it. -20 squared is 400. So this is 8 and -20 over, now this is the square root of 464. Okay, so if I look, this is going to be a bummer, I can tell you already. Square root of 464, darn it, that's not perfect, okay? So what I have to do is break this down. And don't ask me why, but this is one of those really weird common things. I know that 464, I can multiply it, and it's 16 times 29. I think I've just broken it down so many times in my years as a math teacher. That is one that I just know, okay? If you don't know that 16 times 29 is 464, divide it by 2, and you're just going to do a factor tree so we can break this down. Okay, 16 is 4 times 4. 29 I know is prime. So at this point, yeah, I could go 2 and 2 and 2 and 2, but I know I can already cross off 4, 2 4s. If you can cross off 2, you get to write it out once. The square root of 29 is stuck. So this is step 1. That's this part. Boom, 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 boom. Okay, we did that. We have our component form over our magnitude. Now we need to do this so that way we can use scalar multiplication to get our component form. So I take 1 over whatever the magnitude is. 4 times the square root of 29. That goes out front of 8 and -20. Now when I distribute, these are the same as like 8 over 1 and -20 over 1. So when I'm multiplying this in, you guys, I can totally cross cancel. This 8 and this 4 could cross cancel. 8 divided by 4 would give me a 2 on the top. I would have a square root of 29 on the bottom. Same thing here. Top times top, bottom times bottom, it would be negative 20 over 4 square roots of 29. Well, negative 20 over 4 is negative 5 over square root of 29. Again, you cannot leave it like this. I have to rationalize the denominator. So I'm going to go ahead and multiply both top and bottom from both components to the square root of 29. So my component for my unit vector is 2 times the square root of 29 over 29. That is your horizontal value. Negative 5 square root of 29 over 29. That is your vertical component. So here is my unit vector. They want you to prove it. In order to prove that it's a unit vector, you have to show that the magnitude, the distance between 0, 0, and this component is only a 1. So underneath a square root, you square your x component plus you square your y component. So if I square the 2, I get a 4. If I square the square root of 29, the square root cancels, giving me 29. If I take 29 and I square it, I get 841. Plus, negative 5 squared is 25. If I square a square root, it cancels, leaving you just a 29. 29 squared is 841. So now what I'm going to do is simplify the numerators. 4 times 29 is 116 over 841. 25 times 29 is 725 over 841. Common denominator is 841. 116 plus 725 is 841. 841 over 841 is 1, and the square root of 1 is 1. So this is your unit vector, and you prove that, you verified by finding that the magnitude is 1. Okay, again, that's idea number 1 for the day. If you need more practice, there are 3 really good ones in the book. I selected odd ones so that way you could always check the back just to make sure. Okay, now this last part is kind of funky. I've been in a couple different classes when I was studying math in college, and people seem to teach this in totally different ways, okay? So I'm going to show you the way that I think is the easiest way. With us being virtual learning and not in the classroom, I'm not going to show you a whole bunch of different ways. I'm going to show you the one that stuck with me the easiest and just kind of made sense, okay? The unit vectors 0, 1, I jumped ahead. 0, 1, and 1, 0, they are called standard unit vectors, okay? And what happens is, notice that this one has an x value, but not a y. This one has a y value, but not an x. They're unit vectors. If you were to find the distance or the magnitude from 0, 0 to one of these, you would definitely get a magnitude of 1. Okay, so what happens is if you have just an x value, they use the letter I. If you have just the y value, they use the letter J. Okay, so it's a weird thing. Just to be careful, notice this is boldface. It's not italicized, so it's not imaginary. The imaginary unit, if something's imaginary, remember it's italicized and it's not bolded. This is not italicized, it is bolded. It means that you have an x value or the horizontal value of a vector, okay? So what they're telling you that you can do, and this is how the book explains it. I'm just gonna go ahead and show you. What if you had 2 and negative 3? If that was your vector, what they want you to realize is that this is the x value. If you have an x value, you can go ahead and show it as an I. So they're saying you could have 2i. If this is positive, you add. This is negative, you minus. The y value is the j. The second value is the y value, so you could have it as negative 3j. These two things mean the same thing. So rather than writing in component form, you put an I with the x value because it's partnered with this standard unit vector. You put the j with the y value because it's partnered with this unit vector that only has the y does not have an x value. These two things mean the same thing. So again, it's just another notation. It's not changing what we're doing. Okay, so it's kind of cool. Scalars, the scalars v sub 1 and v sub 2, they are the horizontal and the vertical components of v. And I've tried all the way throughout the last video as well as this video. I wanted to make sure that I did call them horizontal and vertical, x component, y component. Because if you were not looking at it like that up until this point, can you imagine how confusing that would be? To me, I needed to know right away, oh, this is the x value, this is the y value. The x value is still horizontal going left or right. The y value is still vertical going up or down. For some silly, strange reason, your book did not introduce that relationship until here. So this should not be new for you. We're just going to go ahead and fill in the blank because it's the point where the book said, hey, guess what? It's kind of like an ordered pair, but you guys are so smart. You already know this like days ago. So here's your vector sum. If you replace this format where you're using i's and j's, it's called a linear combination. So that's just the name of it. A linear combination means it's going to be in this format. This is called component form. They mean the exact same thing. One is not necessarily better than the other. So we're going to go ahead and look at just a little bit. Guys, it's shorter notes today. All right. It says writing a linear combination of unit vectors. We will do 2. If you need additional practice, 51 and 53 in the book are 2 more that are pretty good to try. Okay. So I start off finding that component vector because to me, the component vector makes sense. It's not challenging. So if I have u, vector u, it starts at 2, -5, that's its initial point. If it ends at -1, 3, that's its terminal point. I know I can easily find that component form first. So it's the second x minus the first x. So -1 minus 2. The second y minus the first y. So 3 minus a -5. So my component form, -1 minus 2 more is -3. 3 minus a -5, that is 8. That's component form. Now to go to what's called the linear combination, you would just have to realize that this is the x value. So -3, the x value can be connected with an I. The 8 is positive, so it's +8. The vertical value gets a j. This is the linear combination. This is the component form. They mean the same thing and you're done. Okay, one more just to make sure we've got it. Vector u. You're starting at 0, -2. You're ending at 3, 6. To find the component form, second x minus first x, 3 minus 0. Second y minus first y, 6 minus a -2. So the component form, 3 minus 0 is 3. 6 minus a -2 is 8. Your linear combination form, 3i plus 8j, done. I goes with the x value. J goes with the y value. If they're positive, it's a plus. If they're negative, you show that as a negative. If the y value is negative, it would be a minus. That's all that linear combination means. Okay, now if you're doing operations, they can give you the operations as a linear combination. For me, you guys, I really, really like just working with that component form. And they're not saying that you have to go one way or another. And this is what I mean where there's so many ways that you can do this. I like to go ahead and look at it in component form. So what I would do first is say u, okay? The I means that that's the x value, so that's -3. The j means it's the y value. So this is the same thing as -3, 8. W, the x value is a 2. The y value is a -1. I always, 100% of the time in my college courses, I always change to this because I like to have one way that I could feel in the back of my mind, okay, this is the right way. Yes, leaving it like this is the right way too. But then you're learning a whole nother process. As long as you know that these are equivalent, now you can do exactly what we did on Monday and Tuesday of this week. So if I'm doing part A, vector v is 2u minus 3w. So 2 is scalar multiplying. U is negative 3, 8 minus 3. W is 2, negative 1. So I'm going to bring the 2 in. I'm going to bring the 3 in. So it's negative 6, 16 minus 6, negative 3. So negative 6 minus 6 is a negative 12. 16 minus a negative means I'm actually adding. So 16 plus 3 is 19. This is component form. If they were to say, write your final answer as a linear combination, now you could just go negative 12i plus 19j. You don't have to keep it in this format to get your final answer in that format. I like to work with components. When you take ACT tests and college entrance exams, they will keep it in component form. Okay, so this is a method or the process that you'll see more often than the i's and the j's. Okay, let's look at B. Find vector v if it is equal to 1/2 w. So remember, that's just a scalar. So 1/2, if w is 2 and negative 1, you just distribute. So it's going to be 1/2 of 2 is 1. Negative 1 times 1/2 is a negative 1/2. I put this one in here because I want you to realize that these do not always have to be integers. You can have a fraction. So this could be I minus 1/2 j. It's okay to have a linear combination that has a fraction in it. Last question for the day, guys. V is 2 times the quantity negative w plus 3u. So this is order of operations like hardcore. You have to figure out what's in the parentheses before you ever worry about that too. In the parentheses, I have to distribute a negative into the w and a 3 into the u. So I'm going to go ahead and use all this space. It'll be great. So negative outside of w, 2, negative 1, plus 3 outside of u, negative 3, 8. Okay, so that's the first part. I'm working in the parentheses. Bring in the negative. So it's negative 2, positive 1. Bring in the 3, negative 9, 24. Now I have 2 outside of. If you are adding component form, you just add the x's together and add the y's together. Negative 2 plus negative 9 is negative 11. 1 plus 24 is 25. So I went ahead and I did all of the inside the parentheses. Now I can bring in that 2. 2 times negative 11 is negative 22. 2 times 25 is 50. If they wanted the answer in component form, you're done. If they want the answer as a linear combination, it's negative 22i plus 50j, and you're done. Hey guys, we're more than halfway through the week. I hope you're enjoying all of our vectors. Remember the suggested assignment this time again, what I did is rather than putting it at the end, I put it throughout the notes so you can kind of see where you want extra practice. If you want more practice on this type of problem, check out 55 through 60 on page 434. I'll talk to you guys soon. Have a great day.